All right, Unit 1, Lesson 1 is all about factoring. So you need to know a strategy. How are we going to handle this? Well, if what you have to factor has two terms, we're going to look at that. That's what to do for 3 terms, and this is 4 terms that rarely shows up, but it's on here in case we need it. Let's look at the 2 main ones, 2 terms and 3 terms. When you're factoring a polynomial, that means something that looks like this if it has 2 terms, this if it has 3 terms and 1 variable, this if it has 3 terms and 2 variables, okay? So this one up here could have a number and 1 variable. I'm trying to remember if I've seen one with 2 variables, but this is the general form, okay? So usually when it's 2 terms, you're going to say a number minus another number, okay, or variable. And first thing you're supposed to do is check for a GCF to come out, a greatest common factor. So if you have, I'm trying to think of an example here. If you have 2x squared minus 8, okay, that's 2 terms. It has a negative in the middle. If you notice that it has a common factor of 2 in it, so you want to take that out, and you're left with a perfect square minus a perfect square. That's the GCF taken out, okay? And then how do you factor this 2 square? This will come out and you'll take the root of the first one. So if it's x squared, then its root is x and another x. The root of this last one, the 4, that's a 2 and a 2, okay? And then how does the middle term disappear? Why doesn't it have a bx in the middle? It's because one of them's positive and one of them's negative, and it doesn't matter which one, but when you FOIL that back, you'll get that, because your middle 2 terms will be 2x and positive 2x and a negative 2x, so it'll disappear. So that's how you factor a 2 term. Those can also be 4x squared minus 16. You can take let's make it, wait a minute, that's what happens when I make things up. Let's put a 25 on the end. So it doesn't have a greatest common factor, but 4 is a perfect square. So this could be 2x minus what, 5, and 2x plus 5. That's how you factor 2-term ones. Perfect squares with a minus and then perfect squares. You're not going to get one that's going to have a positive in the middle because they can't be factored. Okay? So for a 3-term, if you have 1 variable, if you have like 3x squared, well, probably shouldn't make one up, there's one at the bottom, plus something with an x, right, plus a number on the end, that's a 3-term, and you're going to have an x squared and then an x. That's the general form right there. You're going to make sure it's in proper descending exponential order. Make sure the 2x, the x squared is first, then x with a 1, and then the constant term on the end, okay? If there happens to be 2 different variables, this is what it's going to lay out wise. It's going to have the squares on each end and the mixed one in the middle. All right, so step 1 when there's 3 terms is to place the 3 terms in descending exponential order, okay? If there's 2 variables, it looks like that order, right? Then you're supposed to check and see if there's a common term that can be factored out, a greatest common factor to come out, like we did over here. If this is like a 6 and that's a 9, you're going to be able to take a 3 out of all 3 terms. Make sure you take that out first before you factor things, okay? Or your answer won't be correct. And then it says to predict the signs of the solution to the problem by using the following. I don't know how else to say it, but this would be the one time you are supposed to memorize something. It just would make your life easier. If you're given a 3-term that has 2 positives in it, right here and right here, that means your answer is going to have 2 positives in it, okay? If you have a 3-term that you're given that you have to factor and the negative comes first, then the positive, then that's a negative factoring. Okay? So those are the two easy ones. Two positives, two positives. A negative then a positive is two negatives. Then the tricky ones. If you have a positive first and then it is a negative, it's different than having the negative first. Okay? So a positive and then negative results in a positive and a negative. Okay? But if you have two negatives in the problem they gave you, it's also one negative and one positive. Order is unimportant as long as you have one of each. Okay, so I would put that on a flashcard and keep that handy. You're going to need that for the whole entire, let's see, lesson 1, 2, 3, 4, 5, everything but 6. Yeah, so lots. You're going to need that for a lot. So go ahead and put that on a flashcard. So after you take out you make sure it's in order. You take out the greatest common factor. You predict the signs of the answer, and then you find all the factors of C. All right, the factors of C. I usually make factor pairs. So if, let's say, I'm trying to factor out an 18. So that's 1 times 18, or 2 times 9, or 3 times 6. Those are factor pairs. So if that was an 18, those are all the different combinations of two factors I could use when I'm factoring. Okay? These pairs need to be added or subtracted from each other to match the signs. Okay? So if you're adding them, this would be a 19, 11, 9. Okay? If you were subtracting them, this would be 17, this would be 7, this would be 3. So it depends on where your answers are going in here. And we're going to do a few of these at the bottom here in just a second. All right, so it just depends. You need to add and subtract each other to match B. So if B was 3, you would use this combination of factors from 18 to get your 3. Like I said, we'll do some of them in just a second. All right, if A isn't 1, most of the problems you're going to be factoring, there's nothing in front of the x squared, or, excuse me, there's a 1 in front of the x squared. You don't see anything, okay? So most of the time, this is all you need to know how to factor stuff. But every now and then, through the next couple of lessons, A is not going to equal 1. So that means you're going to have a 2x plus x plus something or minus something. This 2 is your A term. Most of the time, it'll start with an x squared, something, 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 okay? But if it's a hard one to factor, because I'm going to guess and check these up here, most of them you might be able to guess and check if you have perfect squares or prime numbers. So 2 would be easy because you know that your 2x would have to go here and here, okay? Versus a, if you had a 6, you wouldn't know if it was a 1 and a 6 or a 2 and a 3. Whereas a prime number, it'd just be that number and 1. So those are easy. And then the perfect squares, if you had 4x squared on one side plus something plus 9, let's say, and that was a perfect square and that was a perfect square, then you know you can start out your answer with the roots, okay? And then whatever the middle number is. So those are, you can still guess and check your way to those. And then very few of them you'll need to know the 4-term method. The 4 terms, some of the ones, the 3 terms, if you can't guess them, you have to turn 3 terms into 4 terms using the AC method. So it happens so rarely I didn't put it on here. Some people use the AC method, some people use slide and divide, some people use Punnett squares or the X's, however you factored before. You should have a backup method for the guess and check. And what happens with the AC method is you turn your 3-term into a 4-term, and then you factor it this way. That's the only reason these are on here. Some people like this way. This may not be something you use, but it's on here just in case. Once you've made your 3-term into a 4-term, this is how you factor. You actually divide it in half, get the greatest common factor out of the first half, which in this case is 5b. Then take your greatest common factor out of the second half, which is that, which is a 2. And then the greatest common factor then is, notice both of these are the same, so you put that one time, and what's left you put here. So let's practice these at the bottom here. All right, this number 1 is in the proper form. We have the exponent x squared first, then we have 1x, and then the constant term, okay? Let's see if we can put all this on the same page at one time. Notice that the problem, here, let me clean some of this mess up. Why is it having a problem? Hang on. Uh-oh, what happened? Just had a little hiccup. Let me get rid of some of this mess here. That looks better already. Sorry about that. All right. Let's see. This says x squared minus 5x plus 4. X squared minus plus 4. That's that one right there. That means my answer is going to be 2 negatives. X minus something. X minus something. I know that because there's a negative here and then a positive. Okay? Then I need factors of 4. Well, there's 1 and 4, 4 and 1, 2 and 2. That's all there are. Well, I need to make a 5. Okay? So I need to make a negative 5 because these are both going to be negative. So to make a 5, I can't put a 2 and a 2. It definitely has to be a 4 and a 1. So it doesn't matter in this case whether I put a 1 and a 4 or a 4 and a 1. But that's what this one factors to. Okay? Look at this one here. This one has a positive then a negative. Positive and then a negative. Positive and then a negative is that one, which is 1 positive then a negative. So x plus something, x minus something. You can put that in before I even look at any kind of numbers. All right, and then the c term in this case is a negative 6. So I need factors that make up 6 that are 1 apart. So 6 is a 1 and a 6 or a 2 and a 3. If you subtracted these, if you made the negative 2 and 3 positive, then you'll get a positive 1, which is your b term in this case. See this right here? There's 1 there. All right, so factors of c, that in this case, subtract to a 1. So that means I want my 3 to be positive and my negative to be the 2. That way I'm going to get a negative 2 and a positive 3. Okay, so that's the factoring of that one. This next one, it's got a number in front of the x, so I'm supposed to check and see if it's a greatest common factor, which it is. So this is going to be x squared minus 5x plus 6. And then I need to factor this part. So that's an x, and with a negative first, that's a negative negative. Okay? And then factors of 6 that would add up to 5, that would be a 2 and a 3. You couldn't use a 1 and a 6 for that. That adds up to a 7, right? All right, here's a 2 term. We want to check for a greatest common factor. In this case, we can take a 4 out and an x. Don't forget your factors can be your variables too. So if you take out a 4x, what do you have left? You have x minus 5. Done. That's factored. Okay. How about this one? This one, 9x squared minus 16. 9x squared and 16 are all perfect squares. So 3x, but the root of that one, and 4, 3x and 4, and then 1's plus and 1's minus. Okay, that's done. All right, I could do the next video for the next page.